You ever stop and wonder what's actually going on inside that box on your desk? Or, that super thin laptop you carry around? It's not magic, I promise. Today, we're going to pop the hood and give you the ultimate owner's manual to your computer's anatomy. Let's dive in. Okay, so to really get a handle on all those chips and wires, we're going to use a simple analogy. I want you to try and forget that your computer is a machine. Just for the next few minutes, imagine it's a living, breathing body. Seriously, it's got a brain, a nervous system, and even different kinds of memory.
Think about it, right? Every living thing has a body and a mind. Well, a computer is no different. The hardware, that's the physical body, all the parts you can actually touch. And the software, that's the mind. It's the programs and instructions that tell the body what to do. And here's the thing. One is totally useless without the other. They need each other to do, well, anything, from sending a simple email to playing the latest video game.
All right, so if we're talking about a body, where's the command center? Let's kick things off with the two most fundamental parts, the part that does the thinking and the part that connects everything else together. First up, meet the CPU, the central processing unit. And folks, this is, without a doubt, the brain of the whole operation. Every single calculation, every command you give it, it all happens right here. When you click your mouse, type on your keyboard, or run a program, the CPU is the one figuring it all out. It is the director of the entire show. But hey, what good is a brain if it can't talk to the rest of the body, right? That's where the motherboard comes in. The best way to think of it is as the central nervous system. It's this huge circuit board that literally connects the brain, our CPU, to every other single component. It's the superhighway that lets them all talk to each other. It's the backbone holding the whole thing together. Okay, so a brain needs memory to work. But here's where it gets interesting. Just like us, a computer doesn't have just one lump of memory. Nope, it has two very different kinds, and each one has a very specific job to do.
So on one side, you've got primary memory. This is like your short-term thought process, what you're actively thinking about right now. It's lightning fast, but it's also forgetful. The second the power goes out, poof, it's gone. Then on the other side, you have secondary memory. This is your long-term knowledge. It's like a huge library of everything you've ever learned. It's a bit slower to access, but it holds on to that information forever, power on or off.
So let's dig a little deeper into that primary memory. We find two main types. First, there's RAM. You can think of RAM as your active consciousness. It's the workspace for whatever programs you're using at this very moment. When you close that program or shut down the computer, that workspace gets wiped clean. But then there's ROM. ROM is more like instinct. It holds the super essential, unchangeable instructions your computer needs just to wake up and start the day. It's the stuff it knows how to do without even thinking. So what about that long-term library, our secondary memory? Well, for years, this was the job of the hard disk drive, the HDD. You can picture it like a traditional library with actual spinning disks. But the modern version? That's the solid-state drive, or SSD, and it's a game changer. There are no moving parts, so it's a completely silent, super-fast digital archive. This is the difference between your computer taking a whole minute to boot up versus just a few seconds. It's why new apps feel like they open instantly. Okay, so we've established we have a main brain, the CPU, which is great. But what if a task is so specific, so demanding, that the main brain needs a specialized helper? Well, that's when you get a tale of two processors.
And what's so cool here is the difference in their approach. The CPU, our main brain, is like a brilliant general manager. It has just a few extremely powerful cores, and they're designed to tackle one complex task after another, in sequence. The GPU, the graphics processing unit, is totally different. It's not a manager, it's an army. We're talking thousands of simpler specialists all working at the same time, in parallel. This makes it absolutely perfect for massive, repetitive jobs like rendering every single pixel in a video game or training an AI model on huge amounts of data.
And of course, our digital body has to interact with the world around it. This is where ports and connections come in. You can basically think of them as its senses. You've got physical ports like USB. Those are like its hands for plugging things in. HDMI is like its eyes, sending pictures to a screen. And then you have wireless stuff like Bluetooth, which lets it communicate without any physical touch at all. So, we've built this amazing computer body. But wait a minute, what happens if its long-term memory fails? What about all that precious data? How do we protect it? For that, we're going to need a safety net.
And that safety net is called RAID.
It stands for Redundant Array of Independent Disks, which sounds complicated, but the idea is actually pretty clever. It's a technology that takes multiple separate hard drives and makes the computer see them as a single unit. And its whole goal is pretty simple. Either boost speed, protect your data if a drive fails, or sometimes do both at the same time.
So how does this actually work? Well, it's basically a three-step process. First, RAID takes your file and breaks it into smaller chunks. Second, it scatters those chunks across several different physical drives. And then comes the final, most important step, how it organizes that data. It can either spread the chunks out to get a speed boost, that's a technique called striping, or it can make exact copies for safety, which we call mirroring. Let's start with RAID 0. This one is the speed demon. It stripes your data across 2 or more drives, which means the computer can read and write different parts of a file at the exact same time. It's way, way faster. But here's the catch, and it's a big one. There is absolutely no protection. Zero. If even one of those drives fails, everything is gone. So it's all about high performance, but also high risk. Now, on the complete opposite end of the spectrum, you have RAID 1. This setup is all about safety. It takes your data and creates a perfect, real-time clone, a mirror, on a second drive. Now, you don't get that big speed boost, but what you do get is peace of mind. If one drive suddenly dies, not a single byte of your data is lost. Your information is perfectly safe and sound on the other one. So there you have it, the brain, the nervous system, the different kinds of memory, and even a built-in safety net. Your computer isn't just a box of wires. It's this incredibly complex, interconnected system, with all the parts working together in harmony every single second you use it. So the next time you power it on, just take a moment to think about this amazing digital body you're using. Which really just leaves me with one question for you. Now that you know how it all works, what part of your computer are you going to appreciate the most?